Hello, 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 hello. It is I, Baji's mother, Oinari. Oinari is my nickname for myself. My name is Oindri, and I am back on a live stream episode with you guys to teach physics and talk about physics, our favorite topics, cosmology, astrophysics, astronomy, and mostly just those types of topics: astronomy, astrophysics, cosmology, and physics. Physics is my background, and along with the kitty cats content, I do use the live stream platform on YouTube to talk about and discuss and teach physics. So I'm hoping that many of you will be joining very soon and that I'll get to meet both my old friends of this channel as well as make some new ones tonight. Always happy to see new faces, new usernames, in other words, and make new friends whenever I go live. And I do apologize because of health reasons. I haven't gone live as often as I normally do for the past month or so. I've been doing a few lives here and there, but some of the physics lives have been a little bit on pause, and I'm starting to get back to them. So I do hope again that many of you will be joining, and if you're seeing this later on as a live stream upload under the live tab of this channel, or if it pops up on your the main YouTube page, then welcome and thank you so much for watching, and thank you so much for leaving your comments, your likes, and support. Really appreciate it. So before going further, so tonight, by the way, if you're watching this later, I wanted to get this information out soon. We're going to be talking about cosmic microwave background, which is of course a very important topic in cosmology, and acoustic signatures of the early universe. So to get this organized, to get the topic of discussion for tonight organized, I actually have made some notes for myself already, which is on my laptop right here. That's why I'll be looking in this direction sometimes. So I have these notes already for you. So I will be reviewing them with you tonight. And before that, let me share the live and get things going. So how it kind of works is at the start of the live, I take a moment, make sure all the settings are good, everything is good. Make sure audio is good. Hopefully if you're joining and if you're seeing this, you can give me some feedback on, hello, welcome to the live. Whenever I see somebody joining, I ask, how is the video and audio? Is everything good? Because sometimes I don't know until later on that the live had some kind of problem with the audio. So indeed, I hope that I will find out soon. If there's any issues, then I can try to fix it. But at the same time, I might not be able to fix it. So there is that too. So I'm gonna share the live and make sure all the settings are good, and then we'll get started for the topic for tonight. So I hope that if you're seeing this, it is me. I am live, and thank you so much for joining if you're joining, and welcome. I know it's been a while, so people might be a little bit not used to the live anymore. Welcome, welcome. How are you doing? And if you are joining, please do put something in the chat so I can recognize you and shout you out. Happy to shout out any usernames and say hi to you. And I, by the way, before I get started with the topic, I do like to say hi to everybody who joins. Hello, how are you? Thank you so much for that comment. Thank you so much for the hearts. Thank you so much for being here, guys. Welcome, welcome. And please do put something in the chat and say hi so I can say hi to you. And then also, I can read out your usernames if I can read it, that is, if I understand that language. Hi, Chino. Hi, the first person who said something also with the star. Thank you so much. Welcome to the channel. Chino718 says, blessings to you, Mamita. Thank you so much. Blessings to you. Hi, Faze. Hi, Milestone4 says hi. Tim says hi. Hi, Tim. Read me note. Hello. Lonice Success or Lonice says good evening. Good evening. What you sailing? I don't know what if I'm sailing at the moment, but we will be talking about physics, and we will actually have a little physics class right now. And by little, I mean probably quite substantial. So we do discuss physics, cosmology, astrophysics, and astronomy on this channel, like I was saying earlier before people joined. I'm happy to say hi to everybody. In fact, I'm quite looking forward to seeing many of the people who usually join, as well as new people. Ooh, please do like, share, and subscribe. Thank you so much. Please do like and subscribe. That would be most excellent. Like and subscribe. And I will finish setting everything up, and I will share the live on my channel, and then we will get started for tonight's topic. Okay, so give me just a moment. And I'm also at the beginning of these lives. Cameron, hello. Cameron says, say my name. Hello, Cameron. So at the beginning of the lives, I always try to read everybody's comments and say hi to everybody. And then when I get started with the topic, sometimes there's some good momentum and I'm trying to explain something quite kind of challenging or interesting or difficult. And so I kind of go with that momentum. But then generally I come back to all the comments and I read all your comments. So don't worry if you're saying something in the chat. Make friends with each other, and please like, share, and subscribe in the meantime. And please like the live, double tap to like the live, please. And I always read everybody's comments. Okay, so don't worry, and keep them coming. Dominate the chat. Dominate the chat. Thank you, Cameron. Cameron says you are so pretty. MG Band ZZZ says, yo, hello MG Band. Stephen Elliott says, I really like that you're trying to teach people something new. Your videos have helped me understand. Thank you, Stephen. Oh my gosh. Well, thank you so much, Stephen. It is comments like this that really boosts my morale and encourages me. This is a sort of a tough journey. Kind of doing the physics educational outreach on YouTube is not the normal kind of content. Thank you, Cameron, for subscribing. Oh, by the way, nowadays they let me see the top fans of the live during the live. So if I touch this icon right here, right now the top fans, number one is Supokyk, Supokyk, Supokyk. Number two is the name I cannot pronounce nor read, but thank you so much, number two. Number three is 718RED. Number four is Faze, hello. Number five is Red Me Note. Number six is Loney. Number seven is Stephen Elliott. And number eight is James Tomerlin. Thank you everybody so much for all your support as usual. Please do like, share, subscribe. As I always say, please do double tap the screen so you can like the live. And please do share with any friends or anybody that might be interested. Hi Baji. Hi Shana. This is Baji, the handsome cat behind me, who is also joining this lecture. And please do subscribe. That would be most excellent if you subscribe and keep coming to the channel and seeing these videos and enjoying the live streams and the shorts and the clips and the videos and everything like that. Physics is tough though, so I appreciate it. Thank you. Yes, so physics is tough, and physics outreach is kind of tough too, because it's tough to get eyeballs at a content like this and rank and everything like that. And of course it's just me doing everything, so not always is the production quality of this channel going to be top notch, at least not for now. So I do appreciate everybody's patience as we continue to grow and evolve and make everything better. Okay, I'm trying to start a channel about mental health, but I know it's hard if you don't get any feedback. Oh yes, but you should do it. That's an excellent topic. So yes, I was gonna write that you should dominate the chat. Please double tap to like Baji. What's wrong, Baji? So Baji brought me a toy just a moment ago, and I think so. I had been out. I had an appointment, then I went to the gym, then I had dinner with friends, and so I have been out and about, and so I think Baji is craving some attention, and also now I decided to go live, and here he is, and he brought me a toy, so he needs some acknowledgement at this time. Let me share the live. Baji! Come, Baji. Come, Baji. Okay. Come. কোলে আসবে সোনা? Oh, he doesn't want to. Come, Baji. Come, Baji. Come, Baji. Oh. Okay, let me hold Baji for a second. Then we'll start the lecture. This is the life of a single mother of kitty cats. Give me 1 second, guys. Appreciate your patience. I practice hypnotherapy, so I'm hoping I can use that to help others using that cute cat. Thank you. Thank you, everybody, for liking the live. Thank you for being here. So, Steven, how is the audio? Do you hear any static or any shenanigans? Sometimes that happens and sometimes it doesn't happen. So, I'm really not sure what to expect at this point, and I don't know if it's my device or if it's just the YouTube live that has been that sort of gives up on me sometimes. But either way, appreciate your feedback. It sounds pretty good. Oh, thank you. Gosh, thank goodness. Thank you, Stephen Elliott. Nope, it sounds pretty good to me. Thank you, Stephen Elliott. Have you ever heard of hypnotherapy? Yes, I have heard of hypnotherapy. That's really cool you do that. Join us in chat. Let me get this out and share this to the channel. Otherwise, people will not know. Some people don't get a notification when I go live, so let me do that. Like and share. Hi, Tanner. So I actually have anxiety and I have to do some deep breathing while while I'm working and doing these lives and whatnot. So I appreciate that you're going to cover hypnotherapy and therapy in your, or mental health in your channel, Stephen. I myself very much appreciate that sort of help. So remember Batman? Yes! Are you Batman, Tanner? So top fans right now are Stephen Elliott, #1, Supple Kike, #2, Tanner, #3, and so on and so forth. Thank you, everybody, for joining. Remember Batman? No. Okay, you're not Batman. Okay. Okay. Give me 1 more second. I'm just checking that the live is up on my live monitoring platform here on YouTube. Me and Batman had a roast battle. Oh my gosh. Chino718 is saying digging those earrings. Thank you. These were a gift from a friend of mine a very long time ago. Thank you. Okay, please do like and subscribe. Once again, everybody. In fact, subscription is the main goal right now. I really want to hit 5,000 subscribers, guys. I've been stuck at some 4,000 something number. I mean, I appreciate all 4,000 something of you, but it would be really nice to hit the milestone of 5,000 subscribers. So thank you so much for subscribing, everybody. Okay, guys, so are you ready for some cosmology lessons? So as you know, we talk about astronomy, which is sort of it started out, it's one of the older sciences, it's one of the oldest sciences, but it started off very observational. So when you look up at the night sky and you see those bright little objects in the sky, some of them are stars, some of them are galaxies, Well, the brightest one is actually Venus, and it's a planet. The most bright object in the sky after the sun and the moon, of course. So once the sun sets, which is of course a very important heavenly object or heavenly body near us, it is our star in this solar system. But because it's so bright, we can't see the stars when it's up, when it's above the horizon. But when it goes down, we can see the night sky. And I mean, I'm in Boston, so it's a city. You can't see too many stars, but if you go to a darker area, even around Boston or even around your city that you live in or town or wherever, you can see lots of bright objects. And in fact, you can even see the Milky Way as a band across the sky, depending on how dark it is there. And Milky Way is, of course, our own galaxy, our very own home galaxy, which we belong to. And so astronomy started off as this type of thing, an observational science, looking at stellar objects, looking at the stars, the galaxies. A lot of people thought that these are all stars, but actually many of them, most of them, are actually galaxies, or they might even be binary systems of stars. They're not necessarily a singular star, that sometimes when you look at a bright object, it's actually two objects that are maybe rotating or revolving around each other, and they're part of a team or a binary or a system of stars. And sometimes it's a whole galaxy. In fact, on this channel, a while ago, we were talking non-stop about galaxies, and this is also an astronomy topic. Are you talking live or is this pre-recorded? This is live, my darling. Tyrone, welcome to the live. I'm talking live. So, a while ago, we were talking about galaxies a lot. So I've been going live for almost a year now, and we've touched upon, and we've not even touched, we've probably gone deep into many topics in astronomy, astrophysics, and cosmology. Tyrone says, oh, hello, how are you? I'm okay. I have been recovering, but thank you for asking. I was not so well and whatnot, but I'm trying. So, we talked about galaxies, and we even talked about something called quasars, quasi-stellar types of galaxies. So speaking of the bright objects in the sky, there are even some galaxies that look kind of like stars. They're not really stars. They're actually an entire system or a galaxy, but they're a very special kind of, or specific, kind of unique kind of galaxy. And these are called quasars, for example. So astronomy is this type of study of these stars, galaxies, especially from an observational point of view, making the instruments that can do this type of science and observe these types of bodies in the galaxy, in the universe, whatever you want to call it. So that's astronomy. Astrophysics is where you are more specifically interested in the physics that drives. What about the North Star? What about a 10 mm? So North Star is another example of an object in the sky. I am not specifically an expert on the North Star, but it's there. But so I'm kind of going over what astronomy means and what astrophysics means and what cosmology means, because we're going to actually talk about a cosmology topic. But I first want to go over these. Astrophysics is the study of, more specifically, the physics that drives these different astronomical events. So for example, sort of observing a star, or observing that a star might die, might do a supernova and die, and then observing the stellar remnant that it becomes, which it could become a white dwarf or a neutron star or a black hole. That is astronomy. But then if you're interested in the physics that drives that supernova, or the physics, or the fundamental science that's going on inside of these objects or inside of these events, whether it's a transient event or a more longer event, that is astrophysics. Okay, so very, obviously very interlinked with astronomy, very much overlapping with astronomy is astrophysics, which is more of the physics side of astronomy. And then there is cosmology. Cosmology is actually the science of the universe. So it is not as local, even though astronomy is not local, right? Astronomy still involves very large distances. I mean, our own galaxy, just our galaxy, is 100,000 light years across. So that's not exactly a short distance in terms of what we encounter day to day. But in terms of cosmology, that is actually kind of short distance, because cosmology is about the entire universe. Hello, Afia, Thabasum, how are you doing? So cosmology is not about a star or many stars or a galaxy or many galaxies or the heavenly bodies, so much so, but it is about the birth of the universe, the evolution of the universe, what stages the universe has gone through, how the universe got started, what the fate of the universe might be, and certain mysterious questions that currently still exist about this universe. For example, these are the top questions are dark energy, what is it? We know that it is involved in expansion of the universe. The universe is expanding, it seems, but we don't fully understand it. Then the number 2 question is, what is dark matter? This comes from the fact that seems to be this extra matter in the universe. There's extra matter even in our own galaxy that is quite unaccounted for. It does not interact with light, so it's dark, quite literally. So that's dark matter. And then there's some other questions as well. So cosmology is more big picture, even more big picture, and involves even larger distances. Baji's playing behind me. Even larger distances than astronomy and astrophysics. After this, I will take a deep breath. Nice to see you, Afia. So that's what we are covering tonight, is a cosmology topic. So it's going to be a bigger length scale kind of topic. I'm scared to interrupt, but where are you from? I'm from India originally and currently live in Boston in the US. You can ask questions. Ooh. Let me make a goal. There, I started a goal. Okay, so where are you from, Tyrone? So cosmology is even more large scale, and in fact, one of the hi Roa Alcalde, thank you for the flowers. So one of the questions of cosmology also that I should mention, along with dark energy, dark matter, and it's interlinked to those, is actually large scale structure. So even how the first galaxies got started in the universe so that is part of large scale structure. How did the universe start to form galaxies, right? Basically, galaxy formation, for example, says that some of the matter started to get together and be close to each other and clump and whatnot, which means that gravity in some parts of the universe started to win, and the expansion was sort of overcome in those parts. But overall, the universe is expanding. So large scale structure is another question as well of cosmology. Okay. Hi, Snokomoi. Hello. Hi. Hello, my friend. How are you doing? Hello, Emroa. New York, says Tyrone. I know some people from Gujarat. Oh, very nice. I'm from West Bengal. I'm from the eastern part of India, but the state is called West Bengal. So those are some sort of things to look forward to when we are talking about cosmology versus when we're talking about astronomy and astrophysics. By the way, lots of topics pertaining to all of these I've covered already under the live tab of this channel. If you want to hear something like kind of longer, then I have a lot of live streams that are still posted on the channel under the live tab, and you can go listen or watch those, listen to them or watch them, whatever. You can play them in the background. And then I have little videos or clips from the lives sometimes being posted as videos. And then I also make shorts, of course. And then shorts and videos also sometimes have the kitty cats, quite often actually. So that's what you have to look forward to. And cosmology is one of my favorite topics, and it is also something that a lot of people find to be very fascinating. So today we will talk about something specifically in cosmology, and this is called the cosmic microwave background. Now, to organize this, I have the notes up here already. So I will be defining for you what the cosmic microwave background is. So we'll do that first. The cosmic microwave background, or CMB. So if you hear people in cosmology or physics talk about the CMB, this is what they mean, the cosmic microwave background. And it is an extremely important thing in cosmology. As you can imagine, cosmology is kind of hard to do. Like, given that the universe is almost 14 billion years old, it's kind of hard to picture the universe at a much earlier time or when it was getting started. Because we have the cosmic microwave background, as we shall see, these are photons from a very early time in the universe. This actually quite literally gives us a picture of that early time. So this is why it is of extreme significance in cosmology, and people like to learn about these constantly, or people like to learn things from the CMB constantly in cosmology. It's a very important topic. Talk about that star-based station. I don't know what you mean. Be more specific. The cosmic microwave background, CMB, is the faint afterglow of the Big Bang. So it is photons that are kind of just hanging out from that early time in the universe that we can still see. And it is isotropic and it's homogeneous. No matter where you look, you still find it. So this CMB fills the universe with a nearly uniform glow of microwave radiation. So when we look now, the photon wavelength is actually in the microwave wavelength, okay? So as you know, photons or light has lots of different wavelengths depending on which light, like the optical light versus microwave light versus gamma rays versus X-rays have all different wavelengths. This CMB, we see it in microwaves, okay? Discovered by Arno, Penzias, and Robert Wilson in 1965. So CMB at this point is well understood to some extent because it's also old, but it's still a source of learning for many, okay? So discovered in 1965, this signal provided landmark evidence for the Big Bang theory. While the CMB appears extremely smooth, which by smooth, what we mean is the same in all directions to about 1 part in 100,000. So we can actually define out what smooth is, because it's not completely perfectly smooth, but it is smooth to 1 part in 100,000. So there are little perturbations, there are little spots of overdensity in the CMB, turns out, but for the most part, it is very smooth. So imagine, I mean, when they first saw it and they were studying it, they thought it was very smooth, and I mean, how did anything happen? But then they found that there were actually certain overdensities, but we'll get into that. Sensitive instruments have detected tiny temperature variations, which are imprints of primordial density fluctuations in the early universe. So this is that part, which is that you have to be a very sensitive instrument to pick up on these fluctuations, which are the spots of overdensities, like I was mentioning, because if you didn't have any overdensities, then how would you make galaxies? Because the spots of overdensities later on clumping more would become the galaxies that, like I was mentioning earlier, in connection with large-scale structure topic in cosmology. So you can imagine there are lots of information to glean from the CMB. That's why I'm talking about it. These slight irregularities are the acoustic signatures of the early universe, traces of sound waves that rippled through the hot plasma of the young cosmos. Hi, Stephen! By studying these patterns, scientists can learn about the universe's composition, shape, and how it has evolved over time. So what is more, that there is sort of an acoustic nature to the CMB that we'll learn about today. Because when I first heard about this acoustic waves thing with the CMB and the smooth universe, it was very intriguing. Like, what do you mean sound? You know, acoustic meaning sound. But you'll see, I'll get into what that means, and I think it's a very interesting way to kind of infer and understand the universe. That's why I'm covering it today. But we will talk about these acoustic waves in the CMB. Hi, Stephen. Let me take a few deep breaths and then we'll speak more. Ooh, I can turn this light on. Lighting on versus light off. Oh, okay, I'll have lighting on. Okay, so we'll get into more details of what the CMB means now. What is the cosmic microwave background? By the way, guys, if you want to support the channel and do a super chat, you should feel free. Most welcome. I really appreciate it. The CMB is often called the baby picture of the universe. It represents the moment about 380,000 years after the Big Bang. So literally when the universe was around 380,000 years old. So the universe is more like 14 billion years old now. When it was around 380,000 years old, which is very young, that is when these photons are from. So after the Big Bang, when the hot primordial plasma cooled enough for electrons and protons to combine into neutral hydrogen, because remember, we've talked about how during the Big Bang, things were constantly colliding. Photons, electrons, positrons, they were constantly colliding. They were in this hot, dense plasma, and we couldn't really form neutral hydrogen at that time. Now, remember, quiz question, the most abundant element of the universe is hydrogen, and it is the only element, as well as a little bit of helium and very trace amounts of lithium, that the Big Bang actually made. So basically, all of that is to say that this hydrogen, during the time of the Big Bang, was not even in its neutral form. But at this point, at 380,000 years old or so, it's now starting to cool enough to become neutral hydrogen. Okay, so about 380,000 years after the Big Bang, when the hot primordial plasma, so this is literally the Big Bang primordial plasma, cooled enough for electrons and protons to combine into neutral hydrogen, an event known as recombination. So this is what we call recombination. Before this, the universe was opaque. Photons, or light particles, constantly scattered off free electrons in the plasma. They would constantly interact. Photons and electrons would constantly interact. So all of this scattering off of each other was happening, unable to travel far. So constantly photons and electrons would be colliding. Actually, photons, electrons, and positrons would be colliding with each other in this hot mess, and would not be able to really travel far. At recombination, the scattering stopped and photons were released to stream freely through space, turning the universe transparent. The light from that moment has been stretching, redshifting as the universe expands, and today we observe it as the CMB, a nearly uniform glow at a temperature of about 2.7 kelvins. So it's just above absolute zero. It's not quite absolute zero. It's still there, and we can measure it. Importantly, the CMB is not perfectly uniform. Even though it looks very smooth, its non-uniformness or non-homogeneity is very difficult to pick up on. You need a very sensitive instrument, but it is there. It has tiny hotter and colder patches, only tenths of microkelvins. So only tenths of microkelvins, different from the average. So literally the fluctuations of the CMB are tenths of microkelvins away from the average temperature of the CMB, which is 2.7 kelvins. These temperature anisotropies, so anisotropies versus CMB overall is very isotropic, but there are little anisotropies, appear as a mottled pattern on the sky and correspond to slight differences in density in the early universe. In a sense, we are seeing a snapshot of the universe as it stood only a few 100,000 years after its birth. A snapshot that encodes a wealth of information about what the universe was like and what it contains. And remember, if we did not have these overdensities, we would probably not have galaxies and then stars and us, okay? Because we obviously come from galaxies and stars living and dying and creating, ejecting all of its material into space when a star dies and makes some kind of nebula, and we are from such a nebula. So all of this is, of course, very important to our own personal history. Next, we'll talk about what I mean by the primordial sound. Acoustic oscillations in the early universe is what we'll talk about now. So you know that the very early universe was opaque, meaning the photons were not allowed to freely stream, and everybody was just colliding with each other. The universe was very radiation dominated, is one way of putting it, when those photons, electrons and positrons were constantly colliding off of each other. Things were a hot dense plasma, neutral hydrogen wasn't a thing, neutral helium wasn't a thing, there were no galaxies, no stars, no nothing, just that, and then recombination happened, which is when we made neutral hydrogen. And the photons were released to stream freely through space, thank God, and we've got the CMB from that time. Okay, so in the first 380,000 years, the universe was filled with a hot, dense plasma. That's what we know. Now, this is a plasma of charged particles, electrons, and atomic nuclei. Hi, Adam! Adam, how are you? Are you going to do a super chat to support the channel? Thank you so much. So, tiny density variations, regions that were ever so slightly denser than their surroundings, existed in this primordial soup. Tiny density variations, okay? Under gravity's pull, these denser regions tried to collapse. So, basically, in the universe, let me just pause real quick and reiterate that there's two main things on a larger scale, on a cosmological scale, that you have to keep in mind. One is gravitation. Gravitation is an attractive force. It's not really a force in general relativity, but in terms of speaking, let's just call it a force. It makes matter want to get closer together. So that's one of the important things to consider about the universe. And the other thing is what we call an anti-gravity phenomena, which is the thing that is pushing everything out, which is the expansion of the universe, which sometimes people call dark energy because it's a topic of research. We don't fully understand it. So there was the gravitation, then there is the expansion. Both of those are very important to understand about the universe. I'm feeling the gravitational force to give a super chat. You should feel free, and thank you so much and welcome. Thank you, Adam. Thank you. El Chalin. Hello. So those are the things. I'm going to look at all your comments in a bit. So those are the two important things, gravitation and expansion. Now, remember that if there are not little regions of overdensity in the universe, as in little regions where gravitation is allowed to win, then how would we ever make galaxies and then stars, right? Because these are basically matter clumping. So if gravitation is never allowed to win over expansion, then we would not be here, okay? So, but what led gravitation to win sometimes is a whole nother question, large scale structure, we might have needed dark matter, etc., but that's all linked to this topic, okay? I wanted to tell you about that at this time. So let's see about this. Let's keep going. Tiny density variations. Adam is saying, I'm doing okay, haven't been here in a while. Yeah, I've been under the weather, Adam, so thank you so much, Adam. Cosmos is cool. Oh, I love that so much. Adam has done a super chat. Thank you so very much, Adam. Really appreciate you. So I've been under the weather, so you might have been not seeing the lives because of that, but I do try to post videos and shorts as much as possible to kind of keep things going. And then, is heaven up there? Yes, indeed, heaven is up there. It's part of cosmology and whatnot. So Adam, my bad, not your fault. I've been under the weather is why there have been fewer lives lately. But I haven't seen you in the couple of lives that I did do. So thank you for joining. Thank you for being here. I feel very much more enthused to see people here and your support and whatnot. Thank you for doing a super chat, Adam. Adam Dolson, thank you. Canadian dollars, wow. Love it. And I love your comment. Cosmos is cool. Indeed it is. Thank you. Thank you, everybody. Please do double tap as well to like the live. Ruben, how are you? Hi, Ruben. Hi, Adam. Hi, Tim. Hi, El Chalin. Hi, Steven. Hi, Snookamoy. Okay, let's keep going. So tiny density variations, regions that were ever so slightly denser than their surroundings, existed in this primordial soup. Under gravity's pull, these denser regions tried to collapse, but the plasma was extremely hot and pressure was high. So, you know, whenever there is some kind of high pressure, or radiation, there is actually this thing called radiation pressure as well that we can talk about. But anyway, the plasma was extremely hot and the pressure was high. Falling matter would heat and push back out. So there is a tension between gravity and pressure. So gravity is trying to collapse things, and the pressure of things being hot, the plasma being hot and pressure being high is almost like, it's sort of like this bounce effect. We actually see something like this in stars as well. You might have heard, if you looked into physics of supernovae, and we have actually talked about it as well, within stars and whatnot. Even the sun, actually, there is something called radiation pressure. So when something is really hot and like photons and things are coming out of it, there's actually something called radiation pressure. There's pressure associated with all that material. So it's not a simple, oh, everything here is matter, so there's gravity, so everything will collapse. No, there's also this pressure of things trying to push out. And this is different from the dark energy expansion that I was talking about, okay? Dark matter is a part of this universe. Ekjin. Hi, Ekjin. Basis of a black hole? No, black hole is a stellar remnant. Black hole is what a star, when it dies, when it supernovas, it has to collapse down to something, And depending on the mass of the star, it either collapses into a white dwarf or a neutron star or a black hole. Sometimes black holes can eat more material from its surroundings and become a supermassive black hole. But what we're talking about now is more to do with the universe and the early universe, which was a hot, dense plasma. And there were regions of overdensity in the plasma, which means that gravitation is allowed to win in those little regions and collapse. Remember, this is kind of how we got galaxies at the end of the day. But also, right now we're talking about something even more specific, which is what happened in the plasma back in that time when gravitation was trying to win, but there was also this pressure of the plasma trying to push things out. And that is where we actually get these acoustic waves from. So let me talk about that. Finish talking about that. This tension between gravity and pressure caused waves of compression and rarefaction, just like sound waves. Sound waves are waves of compression and rarefaction. So sound waves, remember, you can only have sound waves travel in a material, right? Like sound waves differ from light waves in the sense that light can travel through a vacuum, but for sound we need like air or matter or something. It's the compression and rarefaction, that is the waving, that is the thing that's waving in sound waves, right? So these ripples basically. So this type of phenomena that was happening in that early universe time is actually learning about the universe from you while doing my coding homework is a real treat. Thank you. Enjoy. What are you? I'm reading my notes actually. These are my own notes that I made about the cosmic microwave background and acoustic signatures of the early universe. I'll include at least some of these notes in the description later on, in the video description later on, okay? But these are my own notes that I've made from various sources. I prepared this while I was sick for you guys. And I'll tell you the sources. The sources are NASA, Planck, and all that stuff. Wikipedia, all of that, okay? So Ruben says pulsars. Pulsars are basically associated with neutron stars. Good point. Yes, please, would love to read them. Yes, so I can share these notes with you guys in the video description later on when I update it. I might even do it during the live. I'll probably do it a little bit, in just a little bit during this live. But basically these are I'm reading from PDF. Like I've made the notes and it's a PDF of them, and I've got sources like what I was mentioning. Wikipedia, Space Science, Planck, NASA's probes, like satellite probes, all those types of things. I've kind of put it together, okay? And it might take me a few lives to get through the whole thing. This is quite long. But these are my notes on the CMB, the cosmic microwave background, that I will definitely include in the video description. Would love to read them. Awesome, yeah. So by the way, if you go back to any of the lives that are uploaded on the channel, like this is live streaming, but then this will become basically a video upload under the live tab of the channel. And then I try to update the lives later on, the description and everything. So I'll make sure to do that for this video and some of the others as well, so you can get all this information. But that's what this is. So this is going to be a little more organized than when I don't know. Yeah, sometimes I use books, and this is sort of like a, I've already compiled it. Okay, so specifically these acoustic waves are something that when I first came across them as a student in grad school, I thought that they were a little confusing. Like, what do you mean that there are sound waves in the early universe? You know what I mean? Like, what do you mean? But actually, they're important because they codify important information in them. So it's kind of important to understand these, and so I've got a simple way of explaining them hopefully here. Okay, so once again, that tension between gravity trying to win and collapse the material because of the tiny overdensities in the otherwise overall smooth universe, and so the tension between gravity as well as that the pressure of a hot, dense plasma trying to push things out is what led to ripples in that hot, dense plasma, ripples that are codified and ripples that are kind of like sound waves, which will tell us things even now, okay? So that's what this acoustic oscillations in the early universe refer to. Hi! Crazy Sick Wine, hi! Hello, Dree. Long time no see. Well, how are you? Looking healthy and beautiful. Thank you. I'm trying my very best to be and remain healthy and take good care of myself. So thank you so much. Appreciate it. I have been focusing on my health almost full time and doing whatever work I can manage. Yeah, because I was kind of suffering for a little bit there. So I had to take some time for myself, and I did, yeah. I did. I had a bit of a health scare. And so now I have to be very healthy, eat well, sleep well, take care of myself, you know what I mean? So hopefully things will stabilize and be good. Yes, I am. I think I'm trying. Better than before now. It's an ongoing thing. But yeah, better than before now. Sorry, thank you, Crazy Sick Wine. You should do a super chat too. Everybody, feel free. Feel free to do a super chat. And double tap to like. Oh yeah, aren't you coming to MIT soon? Oh no! I mean, I hope not. Don't say that, Crazy Sick Wine. No. I hope not anyways. Thank you, universe. Thank you, universe, for keeping us all healthy and happy and well. The health and well-being of all is very much appreciated. Just don't ask me stressful things. Just don't even. I am taking care, that's all. Okay. We'll go back to the cosmology. So these are the acoustic oscillations, rhythmic squeezing and expanding of matter and light, propagating outward from each tiny density kernel in the early universe. Okay? Yeah. I'm very glad. Hang in there. This life is a trip. Yeah, I mean, it can be kind of scary because I have anxiety, and I think I was suffering sort of from a lot of anxiety, stress, and some issues from all that, which can make it very tough, like mentally. So I almost don't really want to even get into it. You know what I mean? But I'm hoping that I'll be much better. My anxiety will be a lot better. It is a lot better now. And I can continue to do my life, or resume my mostly normal whatnot. Drinking helps, joking, but hopefully you'll be okay. Thank you. No drinking for me, so I can't drink, and definitely I can't. I don't even drink coffee now, guys. I gave up coffee. Like, it's and yeah, I had some some acid and digestive issues too. I had to change my whole diet. I've had to like do all these things. Yeah. Yes, I did a lot of changes, diet changes, can't drink coffee, sleep more, eat regularly, grocery shop a lot, try to be low stress. I have horrendous anxiety. Yes, I have a lot. Yeah, I struggle with anxiety as well. Yes, indeed. A lot of high achievers, I think, do. So if you have anxiety, me too. I heard from my publisher. Oh, nice, Steven. Definitely a lot of fruits and vegetables. Did you have anxiety attacks? Yeah. Mm-hmm. Yeah. I did. Yes, I did. Yeah. Yeah, really bad ones. So I've had to really dial it back and be like more. Do you drive? Not anymore. I used to have a car. I sold my car. That was a while ago though. A few months ago. I get anxiety at traffic lights sometimes. But oh my god, that is so interesting that you asked, because I actually did get a panic attack. I got a few panic attacks on the highway, yes. Shortly before I sold my car. When did I sell my car? I sold my car in like April or May. I got a panic attack on the highway. I met some people who have bad anxiety when they drive. I do have bad anxiety when I drive. Do you have social anxiety or in general? I don't know. I think it's general. It might seep to social anxiety, but I think it's general. Let us all deep breathe. Then we'll resume the oscillations of the early universe. You don't need that when you drive. Yikes, I'm glad you didn't crash. Don't even say it, John. Don't even. I was so scared. Because if I'm on the highway, you know that it's because of a mistake. Like my Google Maps is constantly on avoid highway, avoid tolls, avoid rivers, avoid everything. I'm scared for you. I'm not driving anymore, John Foster. I sold my car. So Boston probably has crazy traffic. It does. So I missed a turn and I was by mistake on the highway for like a mile before the next exit, and I totally obviously got a panic attack. It was awful. But that was a few months ago. Things got more, things continued to be or got more stressful and whatever, and my anxiety got a lot worse. So I had to just kind of be deep breathing for like a month, Mine is social because I'm incredibly shy but also good looking, so I don't like when people stare at me for some reason. Oh wow. I mean, sorry, I didn't mean to laugh. That is I'm just laughing. That's great that you are good looking. I know it. That's great. But it is bad. Sorry about the social anxiety. I'm just saying, I'm from Arizona, they drive like nuts. DC has crazy traffic. You'll grow out of it. Who, me? Grow out of what? Driving anxiety? Or anxiety in general? I've always had anxiety with respect to performance. I think I have performance anxiety and just generally anxiety. And I need to like have better, I needed to have like better boundaries and abilities to manage and you know, yeah, day-to-day types of things too. So and yeah, it got a little bit out of hand, and I yeah had some physical symptoms and whatnot and things like that. So it was kind of hard, and by kind of I mean a lot hard. Would you ever get a self-driving car one day? I'm not sure. I don't know if a self-driving car would make my anxiety worse or better. It might make it worse. Yeah, I don't know. Yeah, like I was saying, so it got really bad on the highway, but also, it's pretty good. Like, I'm a pretty good driver in the city, actually. Like, I'm a good city driver. And I can still rent a car if I need, you know. And just maintaining a car was also hard. In Boston, parking, that is very difficult to have a car, actually. So, yeah. But that's interesting you asked about driving. I would say it's more than that. Like I was saying, it's more of a overall life thing. It took me 2 hours to drive like 5 miles in traffic thanks to a bad But yeah, a lot of Americans who grew up here learn to drive at a young age, and they do really well with driving. Boston, I would say Boston is a city where I feel like if you have a car, you should have a driver. Like, it's one of those, like, if you have a car without a driver, then and you're the one who's driving everywhere, then it's not really very relaxing. It's the opposite, right? So I'm a bus taker. I take the bus, the T, Ubers. Do you eat kimchi? That helps me feel good. I don't eat too much kimchi, but that's good to know. Thank you. That helps me feel good. I drink more water now, and milk actually helps me, which reminds me, let me refill this real quick. Yeah, milk helps me. And right now I'm not eating or drinking anything that could be like a trigger, so I had to give up coffee. But I really like coffee, so I'm kind of sad about that. If you have any recommendations, guys, about that. Should I just get a decaf? Would that help, you think? Let me refill this, I'll be right back. Tea, yeah, that's true. I do have tea. I'm in my PJ pants already. Where I live, we have no mass transit, just Lyft or Uber. Milk does a body good. Oh God! So yeah, I have whole milk. None of that skim stuff. Because I'm also working on having a balanced diet where I eat like enough protein, fat, and carbohydrates. So I drink whole milk. That's what I drink in the morning now. And orange juice and water and milk coffee. Hi Mark. Mark is saying a good mint Iced tea feels clean. Mint iced tea feels clean and isn't overwhelming with caffeine. Oh, good to know. Thank you for the recommendation, Mark. Do you like oat milk? Yeah, I would say, yeah. It's pretty good. How long have you been single? I also had a breakup. That doesn't help either. At least when you're single, you're not going to have a traumatic breakup, right? So I don't know what to say. Like, you know, relationships can be good for you, but they can also be bad for you. So, skim milk is not milk. Exactly. I like whole milk. I drink whole milk. Sardines are good for you. People think you'll find someone. Who cares? It's fine. I found you guys. We can just discuss physics and be happy together. I'm happy to find you guys. Relationships are a crazy journey. Exactly. Very interesting, very interesting. Yeah. Relationships, I mean, I think it would be nice to have a good, supportive partner. That would make life easier. I'm open to good, supportive, kind, considerate partner. But a lot of the time, what can happen is that they're not kind and not supportive and very harsh and very traumatizing. And so then that's not good. Well, I missed you. Thank you. Missed you. Exactly. See, Baji, Fuji, and Suji have been taking care of me. They have been most supportive, and thank you, universe. Thank you, God. Thank you, universe, indeed. Thank you so much. Thank you so much, universe, for Fuji, Suji, Baji, and the health and well-being of myself and my children who are Fuji, Suji, Baji, and everybody, and thank you. The health and well-being of us and my Fuji, Suji, Baji is all we need. Of myself, you guys, all of us, all cats, that's really what we need. We don't need anything more. We need health and well-being. Singleness is nice and simple. I'm never happy. Be patient. Baji seems supportive. He is. I am very happy. Wait, Steven, you just said you're never happy and then you said you were very happy. I like it. Where's the lovely Doro and Reese? I know, right? Thank you guys all for coming to this live and commenting. This is helping me immensely. You guys are like my online friends who are supportive. You're beautiful, but we get back to class. Yes, indeed, we get back to class. We do. They have gone back. They have gone with the wind, I suppose. Let me say my like and subscribe. My work is fulfilling. I like that. Did you ever meet your online friends in real life? No. Actually, no. I was gonna say I have one friend that I met on TikTok, but I still didn't meet her in real life. Yeah, no. 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 Oh, by the way, I have been more active on my TikTok as well. It's called Boston Girl. I post about like Boston and whatnot on TikTok. If you have TikTok, if you care about TikTok, you don't have to. You don't have to do anything. But if you're curious or interested, then I have a TikTok, both for Baji the Handsome Cat. I've got a TikTok which is less active called Baji the Handsome Cat. And then I've been posting more on my other TikTok, my main TikTok, which is Boston Girl on TikTok with the same username ONJB as here. And I share more about like Boston and all that if you're interested in that. But you know, the physics and all this is going to be here on YouTube mostly. It's because people like Doro, aw, good job, Steven. Do you want to? I don't know if I can sustain, you know, all that. I have a few friends in real life. I'm more of a hermit. I'm more of a hermit because I'm not really like most people, so I'm more kind of comfortable on my own. More of a loner. You might have to come down to Malibu, get some Cali sun. I do actually. I do want to go back to California. I'm a member at a winery there, and I've never gone back. I should go back. I guess I don't drink alcohol anymore, but the wine there is really good. In Sonoma, Napa, all that. Crazy Sick Wine. I'll get back to the notes and the lecture, but you should say more about the wine in California. Give us some tips and tricks about that, okay? John says, me too. Me too what? But yeah, I'm more of a loner. Is that what you're saying, me too? I have a few friends, but like I met some of my friends today. I feel like people are pretty busy with their lives, and so even with having friends, it's not like you see your friends all the time. So it can be a little lonely sometimes, but at the same time, I think I wouldn't want to get too like overwhelmed either. So Skeletor RA says, hi Skeletor, by the way, hello. Can't go wrong with a Moscato dessert wine. A Moscato dessert wine. When two loners meet, it's a great experience. Okay, sorry, I got a message and now it won't let me minimize my message. Go away. Ah! Oh my god. Sorry. Having Apple issues. I love solitude, but go out maybe once a week. I love solitude. I don't mind going out like a couple times a week or once a week. And I consider the gym going out actually. So I go to the gym at least a couple times a week, you know, touch wood. Touch wood. I was really mad I'm really mad when I can't go to the gym. Because the gym helps with my anxiety, the swimming, the routine really helps with my anxiety. So when I wasn't feeling well, I couldn't do the gym, and that was really hard. So I was doing walks instead, like I was doing walking around the neighborhood or at the park, which is fine. It's also really lovely, and I guess I should appreciate, you know, the summer, the good weather, and whatnot is really nice. But that was really hard. So I consider going to the gym, doing my workout and swimming and all that as part of going out. So I do that a couple times, and then socializing types of things, maybe like once or twice a week, is quite enough. I don't need like a whole lot more than that. Because I'm very energetic when I am with the friends, like kind of like this, you know, like I'm talking a lot, engaging a lot. So then I need like my me time, decompress time, and be safe, safely away from society. Because you're brilliant, your mind is like a pendulum. Oh, thank you. You're very supportive. People will always let you down. Sometimes it's still worth it. Not often though. I'm quick to cut ties because I'm so independent and don't like drama. Have no problem going out places when I can. This is true. I love doing things on my own. Actually, solo travel and seeing the world and new places on my own first before I invite somebody to do things with is very important, because I learn a lot more and I absorb a lot more information when I'm on my own and navigating things on my own, because you're not distracted by whoever you're traveling with and doing the thing with. And I can take a million photos. Like I love like having a date outside by myself where I take a million photos, I do things at my own pace, and I just learn all of it constantly. But it's nice to do things with people too. I think I'm in the mode of like, I want to do it first myself and then take someone there. I don't know. Or I'm also happy if someone wants to take me somewhere and be like, look at all this stuff. Yes, and you get to pick exactly what to do, and you do it. It's not like you have to coordinate with everyone else or whoever else to then do the plan, right? Like I just book things and I go, or like I get a tour booked on Get Your Guides app, quite literally. Like going up to Maine from Boston. By the way, tip from Boston is if you want to go up to Maine and you don't want to drive, just do a Get Your Guides tour up to Maine. And there's like day trips that'll show you freaking amazing spots, and then you come back to Boston and you're back to civilization, you know? Because I don't even like doing these drives, so I just book things and I go. And you're not really alone. If you think about it, like if you went with a partner or a group of friends, you're just going to be distracted by that. I mean, maybe not, but you know, kind of. But when you go with a group where you don't know people, you meet new people. You meet the guide, you listen to the guide. I'm like very particular. Like I have to listen to every word that the guide is saying, and I have to like get my bang for the buck of that tour. Like I want to learn every single thing. So I love solo trips because it's not really all that solo. You go solo, but then you meet new people. There's other people there. There's other tourism things going on, and the world has billions of people. So I think it's gonna be okay if you go somewhere alone. Travel alone, watch movies alone first before I do stuff with people. Oh my gosh, John Foster, you said it. We weren't created to be alone. That's right. That's why you make friends, Faze. You make friends. You're young, but everyone my age has kids. I am not that young. Everyone my age also has kids. I am, I don't know, I think I'm one of the only ones in my cohort. Pretty much all my cousins, the younger ones too, are having kids and all that. So, yeah. Sometimes friends get drunk and you have to babysit. If you're with the right person, it's a great experience. I agree. Very true. Secure and stable person, welcome. I definitely want a secure, stable partner. Yeah, but real people are hard to come by. Kids are expensive and time consuming. Yeah. I couldn't have kids, no way. Yeah. They are very expensive and time consuming. And also they're just always there. like you can't really do a lot without kind of tending to them when they're young, especially. So, you know, I like kids, but I'm glad I'm not a weekend dad, especially looking back at some of my exes. What do you mean weekend dad? It's when you split up and get the kids for the weekend, you mean, or what? Yeah. Yeah, I'm kind of glad I don't have kids. I've got enough going on. I'm my own kid, so a nephew is enough for me. Seriously, I am an auntie of several cousins' kids and my friends' kids, and I'll be a real auntie too soon. My brother, I think I can say this now. My brother is having a kid, so I'll be a real auntie soon. My brother's having a kid, so like in my family. Can you believe that? What if the kid looks like me? So yeah, I feel like enough people are having kids. I don't have to have one, right? Right? Everyone I know, sort of having a kid. Getting older but not growing up. Geez, lol. The fun uncle. You would make a beautiful child. I don't know. Maybe. Maybe I'll make a child. Maybe I won't. I'll just deep breathe and get back to cosmology now. Keep the comments coming. I love it. Thank you so very much. Faze, you should have kids. Go you. Oh, Reese. Oh, wait. I don't know if I can say that. Forget it. Forget it. I was gonna say some people here on the channel that comes to the channel are also having kids. Congrats. Congrats to them. I have subscribers who are having kids. What more do I need? Every blessing of life is here. Me, my kids, subscribers' kids, brother's kid. Thank you, universe. Subhanallah. Thank you, thank you, thank you, thank you, universe. We're talking about cosmology, but currently we're talking about life. Sorry. Faze says I do. Good, congrats, Faze. Faze is a father. Okay, more chit chat in a second. Let's finish up this section and then we'll do more next time. So these are the acoustic oscillations, rhythmic squeezing and expanding of matter and light propagating outward from each tiny density kernel in the early universe. As long as the plasma stayed hot and ionized, the sound waves continued. So hot and ionized means that there will be that pressure to push things out while there's also gravitation trying to collapse things. So that's what's leading to this ripple effect or the sound wave effect. So this was happening until the universe was hot and ionized. But then remember, recombination happened, which is when neutral hydrogen came to be for the first time in the universe. So once the universe cooled enough At recombination, the plasma turned into neutral gas and the sound waves froze in place. Photons decoupled from matter and streamed away, forming the CMB, and the pressure that had been driving the oscillations dropped. So that pressure of the stuff trying to push out while gravitation is trying to collapse things, which has to do with being ionized and hot and crazy, like the early universe, is what was causing the oscillations or the sound waves literally in that early universe hot dense plasma. But once things went through recombination phase of the universe evolution, and neutral gas was made, neutral hydrogen was made, and there was not as much ionization of the matter, then the sound waves kind of froze in place. Photons decoupled from matter and streamed away, and the pressure that had been driving the oscillations dropped. The traces of these primordial sound waves were left imprinted on the matter. The regions that happened to be at maximum compression or rarefaction at the moment of decoupling became slightly denser or thinner than average. Those slight density enhancements are recorded in the CMB as the pattern of hotter compressed and colder rarefied spots that we observe across the sky even today. So these compressions and rarefactions and spots of compression and rarefaction because of these sound waves that froze into place are still something that we can observe across the sky. In other words, the CMB spot pattern is a direct record of the acoustic vibrations in the early universe. So looking at these types of oscillations now and kind of, working it back to what happened back then is very interesting and provides information as to what was going on in the early universe, which is still imprinted in the CMB. So you can understand that among other reasons why the CMB is so important, it even has this type of information coded into it, okay? Because these acoustic ripples were frozen into the matter distribution as well, they also left a subtle mark on how galaxies later clustered. Because remember, the CMB's fluctuations and overdensities, fluctuations from the smooth CMB and regions of overdensity is why we eventually got galaxies. So if you've got information about these overdensities in the form of these acoustic oscillations that are frozen into the CMB, then in a way you also get to know how galaxies started to form, because it's those overdensities are the same reason why we have galaxies eventually, right? So as the universe expanded over billions of years, gravity amplified the initial high density ripples, so the initial high density ripples into galaxies and galaxy clusters. So over time, as the universe continued to evolve, continued to expand, these initial high density or over density ripples later became galaxies and galaxy clusters, while low density regions became vast cosmic voids. So the cosmos is both huge expanses of empty space, which turns out to be not so empty in the particle physics standpoint, but also galaxies and galaxy clusters. So both of these came from these acoustic oscillation CMB stuff, which is really, really interesting, right? It's like really literally primordial stuff that we're talking about now that we can measure in the CMB. Slightly more galaxies formed along the ancient sound wave peaks. So can you imagine? These are ancient sound waves that we can still see coded in there. And these ancient, like literally ancient, because these are from the early universe. And these ancient sound wave peaks, those peaks is around which we get slightly more galaxies. Imagine concentric shells of galaxies tracing where the waves once pushed matter outward. We can still detect this pattern today for any given galaxy there's a slightly higher probability of finding another galaxy about 500 million light years away than at other distances. You should check that, by the way. I'll check the source, okay? These echoes of primordial sound in the present-day galaxy distribution are known as baryon acoustic oscillations. So they've given it a name. The name is not so important, but in case you're interested, the primordial sound in the present-day galaxy, because we have certain terminology that we use in the cosmology studies today, these are called baryon acoustic oscillations. They act as a standard ruler in cosmology. The size of the ripple set by the maximum distance sound traveled before freezing out is known. So by seeing how large that feature appears at various distances, scientists can infer the expansion history of the universe. So even the expansion is something that we can learn about from these sound waves, which is, again, extremely useful. So baryon acoustic oscillations, or BAO, measurements thus provide an independent way to trace cosmic expansion and have helped confirm the presence of dark energy driving the universe's accelerated expansion. So that's another thing. We can also learn about expansion, which is really crazy how much important and useful information can come from these acoustic oscillations. Hi, Eversor! Yeah. Oh, I love that comment. Don't shake hands with the first alien you meet. Toss them something to see if they annihilate each other first. Oh my gosh. That's really clever. Thank you. They could be made of antimatter. Very true. Eversor, how are you doing? Good to see everybody. Did you like and subscribe? Did you like and subscribe? So, did people want to do a super chat? You should feel free. You should feel free. Thank you for the hearts. Thank you. And thank you for any super chat. Thank you. Wait. Who did the super chat? I need to go back. Adam. Thank you, Adam. From Canada. Thank you, Canada. Sorry. Needed a second. Thank you, Touchwood. Thanks to the universe. Doing well. Doing better. So, these acoustic oscillations are incredibly important. Let's talk a little bit about observing the early universe with COBE, WMAP, and Planck. Okay, these are names of certain satellites, observatories, experiments, etc. Oh gosh. And so we'll start talking about these, but we might have to finish it next time because I am trying to go to bed at a good time and rest. So, oh, you know what? This is not too long, but I think I'll still take it to the next time. So by the way, these are my notes that I've made for you guys on this topic that I'll also share in the description. Let's talk a little bit about observing the early universe. Sleep is very important, yeah. Yes, indeed. Sleep is important. Um, but yeah, so we were, I don't know if you joined in the middle of this, but we've been talking about physics, specifically cosmology, and also we talked about life and my anxiety and mental health. Love the intricate topic. Thank you. This is going to be, yeah, these are my notes on cosmic microwave background and acoustic oscillations. And I will put these in the description of the video of this live, which will be under the live tab. So please do check them out later and leave your comments and likes and shares and subscribes. Thank you. Thank you, Crazy Sick Wine. By the way, did you tell us about wine or no? Oh, this reminds me, I need to tell you guys about the Vera Rubin discoveries. I do need to tell you guys about Vera Rubin observations. And about the lady Vera Rubin. She was remarkable. She was remarkable. I'll tell you a little bit about her at the end of this. Actually, that'll be nice. Okay, let me continue for a little bit longer on this topic. So, observing the early universe takes some effort, of course. As you can imagine, we are picking up on a signal from very primordial times when the universe was around 380,000 years old. So very old photons that are at this point stretched out to microwave wavelength photons, and observing these and observing also that these things with enough sensitivity, enough accuracy takes some effort. So we're going to talk about some observation stuff now. So, comparison of cosmic microwave background anisotropy maps from 3 landmark missions is something we can talk about. So, COBE was the first one. Or COBE is one of the ones, one of the missions that observe these anisotropies. COBE is the cosmic background explorer. Sorry, there's no microwave there. The cosmic background explorer, or COBE, is something that you might hear about. It's one of the missions that picked up on this. The next one is WMAP. This is NASA's Wilkinson Microwave Anisotropy Probe. So literally they made an anisotropy probe, so you can see how important this is. They very much wanted to study these anisotropies, and so they made a whole probe on this, NASA. And then there is, of course, Planck, which is a satellite. So the Planck satellite, led by the European Space Agency with NASA participation, launched in 2009 and took CMB observations to the next level. So let's read a little bit about COBE. So NASA's COBE first detected the CMB's tiny temperature variations and confirmed the Big Bang Theory. A decade later, WMAP sharpened the view, providing strong evidence for cosmic inflation and measuring the universe's basic traits with high precision. The European Space Agency's Planck satellite delivered the most detailed all-sky map yet. So a lot of the times when you see that CMB map picture, it's the Planck map, basically, okay? So the all-sky map from Planck, literally giving us a picture of that early universe, is a very famous picture. If you Google it, you'll see it. Resolving temperature patches just 0.08 degrees wide and fine-tuning our knowledge of the cosmos. Thank you, Gino. Thank you, Ocasio. Hi, Ocasio. I'm still here. And your face expressions are so pretty, adorable. I am adorable, thank you. So, the Kobe mission was launched in 1989, and it was the first satellite to measure the CMB in detail. Kobe quickly found that the CMB has a nearly perfect black body spectrum, exactly what the Big Bang Theory predicted for this remnant radiation. Kobe's Ferris instrument measured a temperature of about 2.73 kelvins with exquisite accuracy, silencing doubts about the Big Bang. So, next time, unfortunately I have to go now, but next time we will talk about the Kobe mission, the WMAP mission, and the Planck mission to wrap up this topic. If you're joining recently, please do go rewind and see the full live, okay? We talked about this topic, cosmology, as well as some life stuff. So rewind, please. Thank you, everybody. Please do like, share, and subscribe. Thank you for sharing your wisdom and smile. Thank you. Thank you, Faze. So we will definitely finish this topic next time. It was really lovely to see everybody and catch up with everybody and do a little bit of physics, and we'll continue this next time. I do have to get going and get some rest. Thank you. Bye bye, guys. Thank you.